So whenever we are taking the cross product of two vectors, it's the equation is in such a way: vector A magnitude of vector B into sine theta into n hat. Okay, so it will be vector A into vector B into sine theta into n hat, where the n hat is the unit vector which is perpendicular to the both the plane lying A and B. Suppose these two vectors are there in such a way. Suppose vector A is there and vector B is there. One, it is a unit matrix n. It is a unit vector n, which is a unit vector n which is perpendicular to both the vectors, which is perpendicular to the plane containing vector A and vector B. So this is the unit vector, and its direction is perpendicular to the plane containing A and B. And cross product of two vector A into vector B is equal to magnitude of A into magnitude of B into sine theta into n hat. We will be seeing some terms and condition here. When theta is equal to 0 degree, that means both the vectors are parallel. When theta is equal to 0 degree, in that case sine 0 is 0 and the magnitude of A cross B will be is equal to 0. No resultant. Secondly, when theta is equal to 90 degree, so in this case, whenever both the vectors are mutually perpendicular to each other, then in the cross product we will be getting some values. That the values are magnitude of A into magnitude of B into n hat. Okay. Thirdly, when theta is equal to 180 degree, whenever the theta is equal to 180 degree, the two vectors will be placed in such a way that the angle between them will be 180 degree or angle of a straight line. So in that case, we will be substituting sine 180 degree minus 0. Okay. So in the second quadrant, all values will be positive. Sine 0. Sine 0 is 0. So in this case also, the resultant will be 0. So in the cross product, whenever theta is equal to 0 degree or 180 degree, the resultant will be 0. And whenever both the vectors are perpendicular to each other and we have to calculate the cross product between the two vectors, so in that case it will be magnitude of A into magnitude of B into n hat, and that n hat is the vector, a unit vector which is perpendicular to the plane containing both the vectors A and B. So we have seen the cross product also. Now we will be seeing one particular example, that is known as the resolution of a particular vector, and it is an important concept. We will be describing that particular part also. So the resolution of a particular vector, suppose it is the Cartesian coordinate O, it is the x and y, it is the x part is there and it is the y part is there, and now we have to check how we are calculating the requisite part. Suppose it is the B, and we have to calculate here C. This particular vector is moving in this direction, this particular vector is moving in this direction. This is the resultant. That is the, you can say this is the part of A. We will be dropping two perpendiculars like this and this. Okay, and now we will be checking the resolution part here. So in this case, we will be seeing the particular region here, which is the I, J. So in this case, we will be seeing some of the particular region here. I will show you. So this is the particular diagram, and in this diagram, we will be seeing an important concept that is entitled as resolution of a particular vector. Resolution of a particular vector. Resolution of a vector, that is OA part. So we have to see that how we are resolving a particular vector OA in both the you can say in both the axes, that is x axis and the y axis. And whenever we are taking the consideration of the z axis, in that case also how we are resolving, how we are showing a particular vector in terms of three coordinate axes, that is x-axis, y-axis and z-axis. So we will be taking one example. We have to show OA. First and foremost, OA is equal to OB plus OC. This is the particular algebraic sum of the two vectors, that is OA is equal to OB plus OC. We had already seen, we came across the very first example of the addition of the two vectors, how both the vectors are coinciding with each other, both the tails are coinciding. So how we will be getting the resultant. So this is the particular resultant OA, and we have to show OA in the terms of three coordinate axes, that is x-axis, y-axis and the z-axis. So first and foremost, OA is equal to OB plus OC. First and foremost, we have to calculate OB part. So OB part is this one. So this one we have to see the sine alpha. First and foremost, this is the part alpha. So we will see if we are taking cos alpha. The cos alpha is equal to base by hypotenuse. The cos alpha is equal to base by hypotenuse. It is OB by OA. Okay? So OB is equal to, that is cos alpha is equal to, it is cos alpha is equal to OB by OA. So OB in this case OB we will be writing in the terms of OA cos alpha. OB is equal to OA cos alpha. First equation. Now we will be saying this portion. This portion is beta. So cos beta, this one portion OC. Cos beta is equal to base by hypotenuse. The base will be OC by hypotenuse OA. So we will write OC in terms of OA also. OA cos beta. So we had got the requisite equation. We had resolved. We had written that both the vectors, that is OB vector and OC vector, in terms of the resultant, that is OA. And now we will be substituting these two values in equation number 3. So OA is equal to OA cos alpha plus OA cos beta. OA is equal to OA cos alpha plus OA cos beta. Okay. So we will be writing here, we can write here A cos alpha I plus A cos beta J. Okay. And we have, whenever we are taking the third quadrant, that is Z axis, A cos gamma K. So in this case, we had seen here that we had resolved a particular, in this case we had seen here that we had resolved a particular vector OA in the terms of OB and OC, and we had already got the inputs of OB and OC in the terms of OA, and we had substituted back the values of OB and OC which we had already got in the terms of OA, and we had got the result OA is equal to vector A cos alpha I plus vector B A cos beta J plus vector A cos gamma K, where I, J, K are the unit vectors in the, you can say, X, Y and Z axis respectively, where I, J, K, where this particular portion I, J and the K, whenever we are taking the 3D, in that case the K will come into action, that particular I, J and K, these three particular unit vectors are the unit vectors along the direction of x-axis, y-axis and z-axis respectively. So this is the particular resolution of a particular vector. So this is the topic, resolution of a particular vector. Okay, so we have resolved a particular vector in the term of three axes, that is x-axis, y-axis and z-axis, and we had find out the magnitude of the same in the term of the unit vector matrix, in the term of the unit vectors also I, J and K, which are in the direction of x-axis, y-axis and z-axis respectively. So these are certain important topics which we had described today. The first and foremost, we had described the physics and mathematics. Now we will be coming to the introductory part of this particular topic, that is physics and mathematics. As we had already studied that physics we can describe with the help of mathematics. Physics is the study of laws of nature and how the nature is behaving. So how to understand those concepts, we are taking the help of mathematics. Mathematics makes the physics simpler and easier. So we can say, in the nutshell, we can say mathematics is the language of physics, and we had shown also, we had depicted also the various concepts. We had used the concept of the vector. The very first part we had described about the scalar quantity, vector quantity, how we are describing a particular quantity with the help of those direction as well as magnitude. We had seen the addition of the vector, subtraction of the vector, multiplication of the vector, and we had came across the cross product and the dot product, and we had resolved a particular vector in the term of the three coordinate axis whenever we are taking x, y, z axis into consideration. So these are the certain important topics which we had covered under the subheading of the physics and mathematics, and we will be seeing the various type of the concept of mathematics in the next class also, such as the differential coefficient, the rate measurer, the dy by dx, the slope part, the integral part. So this is the more concrete part of the mathematics which we are applying in the physics so as to get the requisite answer of the complex numerical problems which we are getting in the physics. So we can conclude here that we had taken the help of mathematics in order to solve the complex numerical problems in the physics. In order to understand the physics, in order to render more transparency, we are using the mathematics, we are using the laws of mathematics, we are taking the help of mathematics in the vivid aspects. So this is all for today. I request all the viewers to go through the concept which I had described today. If any issue is there, please do comment in the comment box so that I can check what is the issue, and I will try my best ways to resolve those queries within the stipulated period of time, and it will be beneficial for you as well as for me also. So please like, subscribe, and just share the channel as soon as possible. So thank you for the today.